All right, greetings from my behalf as well. So I'm Eero Jyske, representing an organization called Afiris, a startup company, pan-European, originally from Germany, but we have employees all over Europe. And I'll be talking to you about how your AI, your models are only as smart as the data you give it. And thank you for sticking around with the best track 1, where we also use AI to generate our images that we present. So I've shamelessly also used DALL-E mostly for my generation, and you can see a bunch of typos here and there, and that's on purpose, so I didn't go about trying to fix those typos that the AI is doing. But as Annelise was talking in her presentation, she took us from a bit of past, present to the future. So there's no future unless you understand the past and present, like where did we come from, where are we today, and then where are we actually heading. So I'm going to take a few moments to talk about, first about the past, and then talk about a bit, maybe Tommy's world today, expose what you guys are doing in the future, but then I'll talk a bit about how do we make the AIs better going forward. Annelise also mentioned Alan Turing, so I always tell my wife that the dream job that I want to have one day is teaching the Turing machine and Turing theories in some institution. So if anybody can help me with that, hook me up during lunch. I'd be very happy to take that opportunity. But when I went to the university myself, I already had done years of software development myself, thought I was really clever and fantastic software engineer. Went to the university, first class they make you take, or you get to take, was theory of computation. I took it. I thought it was complete rubbish, and then I spent 4 years in university. Last 2 courses that I took were compilers and artificial intelligence, and then I realized, like, oh, Turing actually had some, clever things to say. So then I redid the class as the last thing I did in university, and I've been a big fan ever since. This is DALL-E's illustration of Turing is my superhero, please make an image, and this is what it came up with. If you are, I highly recommend a movie called Imitation Game, if you're not familiar with Alan Turing and the work that he's done. He's basically the creator of the computer as we know it today. Maybe quantum computing will change that a bit. I'm not going to dive into those details. Other thing I want to emphasize is Moore's law. So Gordon Moore from Intel, back in 70s, already made a projection that the density of transistors will basically double every 2 years and the cost staying the same. So in practice, that means that we're going to double the computing every 2 years and the cost will stay the same. And a lot of the companies in Silicon Valley have successfully used this knowledge and built the empires that they have today in knowing and projecting what compute power will be available in the future, and hence plan their products and their strategies accordingly. There is a Huang's law now. I don't think it's very official yet, but it's much more than doubling. So NVIDIA is currently racing at something like 1,000-fold compute increase with the latest chips that they're doing in Blackwell. So it's certainly increasing, but similarly, we can still predict what it's going to be, and companies should use this knowledge to understand what is going to be possible in the future. Not be stuck with what you can do with today, but what is going to be the cost of doing what you dream of doing in the future. And what has this, in software engineering, what has happened during this, like from the 60s, 70s, since Alan Turing, systems have become bigger, more complicated, we can do more things, and a lot of the work that has gone into development in software engineering is to manage this complexity. And so going from, low-level programming languages, from C, C++, to Java, and lots of the web frameworks that exist today to increase our productivity, but also allow us to build more complicated systems, that we can use. And what we're seeing today is really just an evolution of this, I feel. So when we talk about AI and models, then we talk about data-driven algorithms, right? So you have, anybody being a software engineer here, you've spent time developing algorithms, which I still think is the most fascinating thing in this craft, is actually creating algorithms to solve problems. I think there's still going to be space for these special purpose-built non-data-driven algorithms in addition to specialized data-driven algorithms as well. But this is the evolution now that you no longer need to create the algorithm to solve every problem that you can envision. You can create a generic model feed it data, let it learn from that data, and then that model to be able to solve all sorts of problems you can't even imagine yourself. And this is, the value continuously shifts more towards data. Compute is going to be, valuable. So if you're looking for investment advice, I would still maybe bet on NVIDIA and AMD. So as they say, during the gold rush, the people who get rich are the ones who make the shovels and pickaxes and whatever. So I think that's going to apply here as well. So lots of other people will be successful, but it's more of a hit and miss. But the folks who do the fundamentals, they will be successful. But the other value shift will be in data. So companies that currently are not utilizing their data will be able to do so more in the future. And then maybe a bit of a controversial AI schmai spiel here. So maybe as Tommy was saying, I don't want to put words in your mouth, but these models are in essence statistics. Those are my words, not Tommy's words. So there's nothing like magic happening. It is given data, and it can make decisions based on input that you give it, based on statistics. I think it's not only in our company where this happened, but back in an old organization, AlphaSense, we started looking into building models in 2013. And folks who didn't have background in computer science were looking into studying like how these are done, and then they pretty quickly said that it's just glorified statistics. Like it's like the whole machine learning is glorified statistics. I wouldn't say glorified. It's clever. There's lots of good things being done, but ultimately it is statistics, and that's another important thing to remember. So compute power going up. It's all about data and statistics. Building algorithms is fun. And it's also going to be important. So not everything is going to be done with these massive models. They are also massively inefficient. This is an example that I see popping up every now and then nowadays. The moon lander used a single processor of 2.054 megahertz. And I probably used the amount of compute to generate this image that would take me to the moon and back 10,000 times. So you can still use very low-level processors to solve very specific problems, and then when you can bound them, the Gen AI business or models are not going to be intended for everything. And frankly, I think we should be thinking about a bit the sustainability aspect here on how much energy these models are actually using as we move forward. Then I'll talk a bit about some of the problems with the data. So first of all, this is I think the top number, maximum number I could find about how much of the internet is open. So 10% of the data is actually something that you can access. Rest is all, well, it can be dark web but mostly behind some paywalls and behind corporation data centers. So only 10% maximum of the internet is open. The other one is like most of the 10%, if you go and browse the internet, makes me sometimes lose my faith in humanity. So what people are uploading and generating, most of it is pretty useless. It's also, this is a DALL-E illustration of trolling. So, and then, all these memes. So most of this, if you spend your time in the internet, is how useful is that data really? How much of this 10% is actually like valuable data that one could really access today? And then on the data that gets uploaded, most of it is actually unused. So these are a couple of, I think these have been staying pretty static for a while. 80% of data that gets uploaded to internet is stored but never used. So most of those videos that you saw there, for example, nobody ever watches them. 90% becomes unusable after the first 3 months. So the internet is full of data which is just rotting. Maybe there is something really valuable, but we don't know because nobody's using it. And then dirty data was mentioned by Tommy as well. This is still a problem, and it will be increasingly a problem as we move forward. That how do you, and if you want to build data collaborations that I talk about in a moment, how do you make sure that those data sets are compatible, and how do you make sure that this data is actually not poisonous in any way. So a lot of business and value will be in data harmonization and cleanup for sure, if you're looking for business opportunities. So we hit this all the time. But just worth mentioning, I didn't want to sound like a negative Nelly and then just talk about like how bad things are and this is just statistics and it's a scam and whatever. I mean, we're doing amazing things like Relex is doing and most of the organizations are doing amazing things already today with AI, given all these limitations that you have. But in the future, and this is the only image which was not generated by AI, one of my favorite movies. But what will be the future about then? So if we maybe recap my talk until now, so I talked about how we're on a journey from Alan Turing's creation, the computer, creating more and more compute, taking us to the data-driven algorithms. And right now, the next step, given all those limitations with the availability of data, the next step then being how do you make data more accessible? Where is this data that we could actually use for better common good? And this was the illustration of siloed data in the internet by DALI. And as I mentioned, a lot of this data, the 90%, is actually, which is not accessible, it is in corporations. And corporations using it for their own applications and improving their own operations today. And yes, this is something you can do. I mean, you can take off-the-shelf LLM model, you can feed it your data, you can create already a very clever customer service agent or things to solve your internal company problems. But it's not going to help you collaborate. It's not going to help you maybe take the next step. Your customer service agent will only be as good as your customer service is today. But if you would want to create the best customer service ever on the planet, the way to do that would be to combine the best possible customer service data from all the customer service organizations on the planet. So one example, and this is now I'll come to what Aphiris is doing. So we're not bound to healthcare, although right now we are very focused on healthcare as a field. Our product that we built for distributed machine learning, and again, I'll talk a bit more about that in a moment, what that means. It can be used for any industry, any application. But healthcare is really where this problem is already known. It has been visible for years. And also this staggering number of, well, most of the data in the world is actually being generated. Of all those, 80, 90%, well, I mean, maybe not all of this goes to the internet, but all of the data that gets generated on a daily basis in the world is 30% and growing is healthcare. So it's devices like this. I mean, most people have like rings and watches. It's hospitals producing data. It is pharmaceutical, biomedical companies, government organizations generating this data. And what is specific about also why this is a beautiful problem for Aphiris to solve, as a first case example, is that this data really doesn't want to move anywhere because of regulatory reasons, first and foremost. So it is highly sensitive personal data typically, so it needs to be protected. The data is also valuable, and I think this is going to be maybe this talk or the other talks that we'll do, in the future, but it's going to be a wake-up call for many organizations also to see your data is valuable. So don't give it up to anybody just, for free. Make sure that you find a way to monetize it. Either you monetize it for using it to your benefit, or then you find a way to sell your data to somebody else. So there is massive value in potential collaboration, and better data we have, better models, better results we can collectively get. All right, federated machine learning, in a nutshell, and this is the Aphiris product in the next 2 slides here. Normally when you do machine learning or data analytics, you have your data in your own data center, whatever it is, on-premise, Azure, AWS, GCP, whatever. And then you're able to pull all the data together in a single data storage basically and train your algorithms there. Everything good. You can also, companies have been collaborating since forever, since they've been collaborating on data, and you can bring data together in your own joint data clean room with certain regulatory protection and whatnot, contractual protection, and then jointly use that data for training an algorithm. But if you truly have data, which I believe is going to be the increasing and more prominent thing going forward, that does not want to leave a company's or a certain infrastructure, then you have to use a federated machine learning model, which effectively means that you have multiple data centers, which I illustrated here in the green circles with the shield in the middle. And they are what we call the data custodians, who then own and manage the data that resides in these data centers. And the data custodians always have the right to, or they have the control to say who can access this data and with what kind of parameters. So for example, organization A can run their machine learning model in my data center with 3 rounds of training or whatever, and with these and these kind of parameters. And that all can be governed and controlled by, for example, our product. And you can do this with one-to-one relationship. So you would have a machine learning engineer who wants to train their model, can submit it to this data custodian, have it trained on the model, and get the model back. Or you can have multiple data centers collaborating all at once, hundreds of data centers, if you will. And then the model gets trained in each one of these data centers separately, and then the results are aggregated, and the system handles the training runs, multiple training runs across all the aggregated data. An important aspect here is really the data custodian, as we've learned that whoever owns the data needs to have and needs to feel like they have control over what happens, and always have the opportunity to pull the plug if needed, and really see what's going on. 3 main pillars here, because I'm shamelessly also overlooking some of the complexities that clearly are to be solved still. We have some solutions for these, but lots of innovation still to be done. Our governance, privacy, and security, and maybe starting with security. So this is the simplest one. So your classic, your data is in your data center, and the system will guarantee that this data will not leak out of this system. So it cannot be stolen, it cannot be retrieved. So the system is secure. Privacy. So anybody here who has any experience training models will understand that if you train a model with given data, it will know that data to some extent. So even to the extent that it knows the whole data. So you could basically train your model, send it to somebody's data center, have the model trained, get your model back, and then just ask the model that, hey, okay, tell me all the data what was in this data center. So privacy mechanisms are, they do exist, and more will be developed. This is an area of rapid innovation at the moment, privacy enhancing technologies. That how do we guarantee and how do we analyze a model to make sure that it does not leak sensitive data. And then the third item being the governance, which is then more of the access control. Only the people who have rights to access the data can do so, as well as then paper trail being left for every action that has been taken. So there's still a strong legal and governance aspect to these kind of data collaborations going forward. Great. So that creates the computational governance. So ultimately, I always make our head of security very happy when I describe our product as a remote code execution platform. So, but that's ultimately what we do is we enable executing any code in your data center if you give the permission, given the analysis and the privacy protections that are in place. Cool. And the future that we would like to see evolving is then, right now, if you look at the collaborations where we set up a machine learning engineer to interact with multiple data centers, there's still a need for a third party like us to take part in facilitating and providing technology for this collaboration. But in the future, obviously technology is still needed, but there really shouldn't be a need for the middleman in between. So making the data collaboration more day-to-day, so that whoever has valuable data, you can install this compute gateway type of a device in your data center. You can publish, announce what kind of data you have. You can create examples, and you can give metadata to describe your data sets and then monetize them to the interested parties, and thus creating more of a data ecosystem where data custodians, data owners can advertise what they have, and then similarly the organizations that want to use this data can find the meaningful data sets and create these collaboration opportunities. So again, going back to what I said about there's the direction then with value being in data will create opportunities for organizations that don't necessarily use the data themselves, but can use what the data they have to enable somebody else to do research on whatever they're doing. One example of things that are already happening on this front, so I don't know how many follow the Nobel Prize ceremonies. I didn't usually, well, maybe the only one was the Peace Prize, but this year the chemistry was remarkably interesting because in fact, one of the use cases that we are helping empower is the protein structure prediction, which is fundamental to a lot of medicine and drug development and other advances in the healthcare. So if we can find ways to predict various protein structures, it helps us, accelerate finding cures for lots of diseases and whatnot. And the two gentlemen here, Demis Hassabis and John Jumper, they actually from Google and been developing this AlphaFold model for protein structure prediction. And then David Baker from Baker Labs in University of Washington. He's a trailblazer in synthetic protein creation. His lab specializes in that. So all of these right now still not fully taking advantage of the possibilities of joint data being used for the prediction. But these are the types of use cases that we're enabling going forward. So having the protein structure prediction models, but use actually more and more data, and they will become more accurate, and they will be able to predict more and more and better results. Quite exciting, actually. And I think David Baker would be one of. I was just watching on Sunday Arto Nyberg, the talk show here, and Peter Sarelin was there, another superhero, almost as superhero as Alan Turing. But he was talking about the professorships that he wants to establish in Finland now that Silo was acquired by AMD, and superstar professors that we should attract to Finland. And David Baker, certainly, not to say that he would move, but the types of people that you would like to see moving here. And you can really see that I think this computation and data computation collaboration will create more and more opportunities for various fields where we could use machine learning for more and more. And academia, I think, is going to be driving a lot of these and these kind of very advanced labs that universities house at the moment. Cool. So I'm going to close off with a video and maybe just to remind us all on the topic of my talk, which was your AI is only as good as the data you give it. Maybe the other point is that be kind to the robots because they learn and Skynet may be coming. There you go. So it was only as smart as it was the data that it had. And thank you for your time and attention.